Oh, there was one other thing that I didn't say, and I'll say it again at the end of class, is this week we have one thing due, and that's quiz 4 over the Venn diagram content. Um, a week from now is our review for exam 1, which means exam 1 is next week. And to go along with that, I want you to be thinking about setting up your appointment for exam 1, whether that's going to be at a CSN testing center or with ProctorU. Make sure you get that appointment set up as early as possible. The deadline for that exam is Thursday, the 28th. We will not have a class meeting on the 28th. So if you want to set up your appointment to take the exam at 11 a.m. on Thursday, the 28th, when we would normally have class, you can do that. We won't have a class meeting that day, so that time's open and available for you to take your exam then if you want to. The exam will be available on Tuesday, Wednesday, and Thursday. So you can make an appointment at any time on those 3 days. But if you want to take it on Thursday during our class time, you'll be able to. And I'll probably say all of that again at the end of class today, and certainly on Tuesday of next week. Also, tomorrow, I will send out sort of a lengthy, sort of the weekly update for next week that's about the exam 1. I'll send that out, and you'll be able to read through it and ask questions if you have them. Of course, Courtney, go ahead.
So sorry. Is the exam due at the end of what time class would be on the 28th?
Great question. No, it's not due until 11:59 p.m. And so if you're taking it, our testing centers close at 5. So if you're taking it at the testing center, you don't have till 11:59 p.m. If you're taking it with ProctorU, the deadline's 11:59 p.m. You do get 90 minutes for the exam. It'll be 20 questions, 90 minutes. The way to think of that is like a double quiz. Our quizzes are 10 questions, 45 minutes. The exam is going to be 20 questions, 90 minutes. So it's essentially the same pace as far as how fast you have to work. It's the same as the quizzes. It's just twice as long, twice as much time to complete it, and twice as many questions. That being the case, you get 90 minutes to complete the exam. So you don't want to set up an appointment with ProctorU at 11 p.m. In fact, I don't think you can. I think the latest they'll let you set one up is at 10 p.m. And that's because you have 90 minutes. And so 90 minutes would put you at 11:30. That's before the deadline, ProctorU. So that's that. And with the testing center, if you're taking it there, make sure you set it up early enough that you can finish before they close. Let's see, Nicole's question. Yeah, Tuesday will be our review for the exam. And then Thursday, and that's the only class meeting we have next week, is the review for the exam on Tuesday. And if you wanted to set, our review for the exam is going to be from 11 to 12:30 on Tuesday. If you want to take the exam at 1 on Tuesday, you absolutely can. Or you can take it later on Tuesday, anytime Wednesday, anytime Thursday. Just remember that the deadline is Thursday. Yeah, I'll still have office hours next week, Natalie. Absolutely. Oh, perfect. If you decide you need to ask something else, Courtney, you go right ahead. No, not if you come during office hours. No, you can just show up, Natalie. That's just fine. And if there's more than one person there, I'll manage it. We'll make sure everybody gets a chance to ask their questions. Okay, yeah, first exam is a little mysterious, so I don't mind, any or all questions related to that. And, the main things to be aware of are that you'll want to have an appointment. It's 20 questions in 90 minutes. You're allowed to use a calculator. You're allowed to have one page, front and back of notes, whatever you want on there. Just make sure they're in your handwriting. And then, did I say calculator? You're allowed to have a calculator. You're allowed to have scratch paper. Calculator can't be on your phone because you can't use a device that would connect to the internet. And then, anything else y'all think of that you want to ask, it's completely fine. And again, we can talk about it later on today. We can talk about it on Thursday, and certainly on Tuesday of next week, we'll talk about it quite a bit. And that email I'll send out tomorrow will have a lot of information sort of listed out so you can read it. And sometimes that's easier to digest than, just hearing somebody say it one time. So if you want to use the calculator that's inside Canvas on the quizzes, you can use that one. That'll be just fine. Yes, Social, you bet. That is a good question, Courtney. I'm not sure. But Xochitl mentioned there is a calculator inside Canvas if you want to use it. Basically, next time you're working on a homework assignment, you'll and I can send you an email with a little image, but there is a little calculator you can click on and it pops up in the window. Some people find that distracting, so I haven't really mentioned it, but if you want to use that one, you absolutely can. That one will be okay because it's built into Canvas, so really you're not using an external resource. All right, let's talk Venn diagrams. Venn diagrams were created by an English mathematician named John Venn, named after him. And what they are is these give us a way to represent sets and their elements with a picture. Up to now, we've represented sets in roster form. There's a set, and we might even give it a name. Set A is equal to this, and that's a set for us. Now what we're going to do is we are going to move over and look at using pictures to describe sets. Some of you who are very artistic or very visual might like this a lot. Others, if you're a little bit more like me and you're not very artistic and visual can sometimes be a little challenging, you might need to put in a little more work on these. But with practice, they get much easier relatively quickly. So I think you can get there. I'm confident you can get there. Let me rephrase that. So here's an example of what I'm talking about. If we wanted to talk about a two-set Venn diagram, and we were going to make a circle for red shapes, so that's set A, red shapes, and over here we were going to make a circle for rectangles, and that's set B. And that's pretty good, right? So I decide I'm going to have this shape here. Is that going to go in set A or set B? That red triangle. Set A. Perfect, Nicole. I don't know, Leslie, is that a rectangle? Okay, perfect. So my red triangle goes over here, and then, okay, well, that's all fine. What if I draw this shape here? This blue rectangle, where's that one going to go? You're okay, Leslie, it's no problem. That's going to go in set B because it's a rectangle. And then the thing that would trip us up, and I think this is kind of where Leslie was pointing and was sort of anticipating what I was going to do is, well, what do I do with that one? Now I have this red rectangle. It needs to be in A. It also needs to be in B. What could I do with my diagram so that I have a place for this shape to go? Overlap. Perfect, Courtney. So, and that's exactly what John Venn did. Great, Natalie. When John Venn decided to make Venn diagrams, what he did was he decided to create a two-set Venn diagram this way so that the shape that is a red rectangle has a place to go. It goes in the overlap. It needs to be in both sets, A and B. Hopefully you're hearing a lot of words there that have meaning because we're going to talk more about those later on. Let's continue with our two-set Venn diagram structure. So your basic general two-set Venn diagram is going to look like this. We're going to have set A over here. We're going to have set B over here. And we're going to have a rectangle around it. The rectangle around it will be important a little bit later on. For right now, just kind of play along with me and understand that it needs to be there. What we've done here in this Venn diagram is we've created four distinct regions, and we're going to name those regions. We're going to name them using Roman numerals. We're going to have region 1, region 2, region 3, and outside the circles, region 4. Those are our 4 distinct regions. In our book, you may see a picture that uses the numbers we use, which are Hindu Arabic numerals. We're going to talk a lot more about Roman numerals later in the semester. For right now, just 1, 2, 3, and 4. And the reason we use Roman numerals to describe the names of the regions is because the numbers we normally use will have a different purpose on Thursday. So, Roman numerals to describe those regions, regions 1, 2, 3, and 4. What we're going to work on today for most students is more challenging than what we're going to do on Thursday. So normally you kind of climb up the hill and you get to the hardest thing last. I don't think that's true for Venn diagrams. I think for Venn diagrams, what we do today is more abstract than what we do on Thursday. Today, we're going to be shading Venn diagrams. We're going to color in some of these regions. When we get done with our picture, some of these regions will be colored in and some will not. It's kind of an abstract process. On Thursday, we're going to be problem solving, which is a lot more concrete. So today's going to be a little abstract and it might take a little practice. Let's take a look. So if I want to shade a 2-set Venn diagram, and some of you may have seen this before, some of you may be really comfortable with it, fantastic, that's great. If I want to shade A intersect B in a 2-set Venn diagram, the first thing I'll need is my 2-set Venn diagram. So I'll have A, B, and the rectangle around them. And if I want to shade A intersect B, now some of you who are sort of abstract thinkers or very visual or really artistic might come to this conclusion immediately, and that's fantastic. You might think, well, I can see where A intersect B is. I'll just color that in and be done. Fantastic, if that's you. And if you get to a place, even during class today, you may have never seen this before, and we get to a place and you're like, well, okay, now I know where A intersect B is. Can I go straight there? Yes, you can. But to start out with, we're going to look at this kind of like a cartoon strip where it has several panels that we work with. So we're starting out here with A intersect B. If I want to know what A intersect B is, I don't have any parentheses. I'm going to work left to right. The first thing I'm going to do is I'm going to shade set A. When I shade set A, I color in everything inside the A circle. I'm going to shade it like that. So there is set A. If you have any questions about what I've shaded, you let me know. If you're thinking, hey, part of that's in B, you're right, part of it is. What I was told to do is shade set A, and that's anything inside the A circle. Don't overthink it. If you're shading A, you're shading A circle. Now what I want to do is I want to shade where this intersects with set B. Remember the word intersect. Intersect is where the 2 sets overlap. What they have in common, the elements that are in both sets. The elements that are in set A and in set B. So what I want to do, I need to be able to identify the overlap. So what I'm going to do here, because I'm looking for the intersection, is I'm going to shade set B the other direction. Shading set B means color in the entire B circle, and I'm going to shade it the other direction. I have the advantage of having multiple colors. You may not. And that's why I've shaded it the other direction, is because when I'm looking for the overlap now, I'm looking for this crosshatch where I have both things shaded. That's where I can identify my overlap. And then as I look at this, I can see where the overlap is. I'll ask you, what region is shaded in the overlap of these 2 sets? And we're using those Roman numerals from before. Courtney, they'll say you're allowed to use the actual 2 for this one. I'll allow that. I just want you to be aware that that Roman numerals will be our standard thing, but it's perfect. Courtney is Dulcie is perfectly fine for y'all to use a number 2 there. There's nothing wrong with that. Because you're telling me region 2, and that's perfect. You can look at this picture and see that right here is the overlap of those 2 sets. That's where A and B overlap. I don't want to leave my picture like this. The cartoon strip thing that I mentioned before is to have a nice clean picture to finish off with. If I'm going to shade A intersect B, what I'm going to end up with then is just this region right here shaded. So this is my picture of A intersect B. It's where those 2 sets overlap. What we've done is we've colored in the elements that are in A and in B, the elements that are in both sets. These 2 words here go with intersect. So does overlap. Any questions about what we did there? We will do some polls today, but not yet. The next one we're going to draw is shade A union B. If you want to take a second and try that on your own before I get started, I think that's a great idea. And then you can ask questions if you have them. Again, I'm going to start with just set A, set B, and my rectangle that goes around the outside. I have 4 regions, regions 1, 2, 3, and 4, and I'm going to shade that, A union B. Union's a little different than intersection. We know that, because union, I'm just going to join these together. I'm not looking for the overlap when I do the union. Instead, I'm just going to join them together. I want to shade the elements that are in at least one of the 2 sets. The elements that are in A or in B. If you're in A, you're great. You're in the union. If you're in B, good. You're in the union too. We're not looking for the overlap here. We're letting everybody in. And so because of that, when I go to shade, it'll be a little bit different process. Here's what I mean. I don't have parentheses, so I'm going to shade set A. And now I want to shade set B. And here's the difference between union and intersection when I go to shade. I'm not looking for the overlap. I don't need to find the crosshatch. Instead, I'm just joining them together. I'm going to go ahead and shade set B in the same direction. And then I end up with regions 1, 2, and 3 shaded. There's my picture of A union B. Let me know if you have any questions about that before we go forward. And since we didn't need to look for the overlap, we didn't really need to draw another picture to show the answer. Section 2 is shaded as a part of our final answer. Yes. Yes, Courtney. Region 4 is not shaded because we colored in A, we colored in B. We joined those together and that's it. As far as your question about region 2, Courtney, let me do this. If I asked you to find A union B, I'm hopeful from last week, what we would have then is, well, let's join those 2 sets together. That's 1, 2, 3, 4. If that makes sense, well, okay. The only element that was in both sets was the 3. That would be in the overlap of the 2 sets. That's what would be in here. Well, that's a part of our union, so we better shade that too. We're not throwing anything out. We are shade anything that's in A, we keep it. Anything that's in B, we keep it. And so regions 1, 2, and 3 end up shaded in A union B. Perfect, Courtney. And any questions that anybody has today, please ask them. The abstract nature of this. When we were looking at concrete things that had numbers, that a lot of students grasp onto that right away. The abstract nature of these pictures can be a little bit challenging. And so I want you to ask questions when you have them, because I'm almost positive somebody else has the same question. Leslie asked about region 4. So region 4 must do something. Let's see what region 4 does. If we want to bring the complement into play, so let's say we want to shade B complement. I will tell you, complement is the thing that causes students the most trouble with these. Kind of the same with when we did them in roster form. Okay, if I want B complement of this two-set Venn diagram, so I have A, B, and I have this region out here, I want to shade B complement. So I want to think about this for a minute. B is everything inside the B circle. That means B complement is everything that is inside the universal set. That's what this is for. That gives us our universal set. But outside of B. So inside the universal set, but outside of B. Okay, well, that's all this stuff. And then I have to be careful. There's a little bit more. There's this over here. Okay, so outside of B, but inside the universal set, that's what my picture is going to look like. It's going to be regions 1 and 4 will be B complement. Outside of B, but inside the universal set. I kind of think of this like a light switch a little bit. Like if I were to shade B, it would be all of this. Now what I want to do is turn the light switch the other way. So whatever shaded becomes unshaded, and whatever wasn't before, now it is. The complement is like turning the light switch on and off. It's the negation for any of y'all who might be English majors. If B is our statement, then B complement is the negation of that, everything else. So it's everything that's not inside set B. Please ask me questions if you have them. The complement will be the toughest idea that we talk about today in shading these diagrams. If that made sense, that's fantastic. We're on a good start, but they will get more challenging. So hey, so stick with me and ask questions when you have them. All right, let's look at A complement union B down there. We want to shade A complement union B. You can absolutely try it. I'll kind of delay for a little bit before I get started on it. You're shading A complement first, and then union, so we're joining that with set B. There is one issue here that might make you stop and think for a minute. I think that's okay, and I promise we'll talk about it. I'm going to get started in just a second. Maybe you've had a chance, maybe not. I'm going to start with my two-circle Venn diagram with A and B. I need my rectangle because there's some stuff that's outside those two sets that would be involved. And let's see here, I need A complement union B. So the first thing I need to do here is shade A complement. That's everything outside of A. So that's all this stuff. And then outside of A is going to be over here. Be careful. We don't want to include region 2 because region 2 is a part of set A. So it's not in A complement. Part of the reason that we give those regions names, 1, 2, 3, 4, is so when I say region 2, you know exactly what I'm talking about. And so region 2 is not shaded here because it's inside A, and we want the stuff that is outside of A. That's what A complement is. Now I'm going to join this with set B. It's union. I'm going to join these together, which means I'm just going to shade the same direction. I'm not looking for the overlap. I'm just joining these things together. So now I'm going to join this with set B. Okay, here's set B. And then that's my final picture right there. And what I end up with shaded are regions 2, 3, and 4. there's something I want to say because somebody might be thinking it, and I might be able to get ahead of you on a little bit on this one. With complement, sometimes students will fight the idea that, wait a minute, you said a complement. Why is this shaded in our answer? And it's an excellent question because, hey, it said a complement. Well, why is this here? And the reason that region 2 is shaded, anybody want to tell me why is region 2 shaded here? Because I think this is it's a really key concept. It's a really important question, and it's one that a lot of students have. Why is region 2 shaded? It's at a complement. And there's a lot of different ways to phrase this answer. Because of B. Excellent, Michaela. Excellent, Courtney. Yes, Stephanie, because of union. Yes, Moylan, because of it's joined with B. Outstanding. Great comments. So you're exactly right. It's because we joined this with set B. So no matter what else happens, we're joining this with set B. So all of B has to be shaded. If some of that happens to be different than a complement, so be it. Because of union, all of B has to be shaded. And so that's why region 2 is part of our answer here. All right, I'm ready to let you try one. Before I do that, are there any questions that we should address? Outstanding. Here it goes. I want you to shade B complement intersect A. I'll set up a poll for this one and give you a little time to do it. And so what the poll is about is what regions are shaded. You might be thinking, how are you going to ask us to do this on a quiz or an exam? Because we can't draw a picture and have you see it. You'd be exactly right about that. But what I can do is I can ask you to shade that and ask you to tell me the regions that are shaded. And so you could type it in. Whatever regions are shaded, you just type that in. And we know they're named by Roman numerals. Another way I could ask it is I could have you shade this and give you several pictures and make it a multiple choice question where you identify the picture that's correct. So those are the two most common ways that I could ask this. I could also say what regions are shaded and make that multiple choice also, kind of like this poll. So take a minute, draw this picture, and then we'll take a look at it together in a couple of minutes. If these are challenging at first, that's okay. That's typical. With practice, they get easier. The abstract nature of these, not knowing what elements are in the sets, is a little bit hard to wrap our head around at the beginning. But with more practice, they get easier and easier to do. All right, let's go another 15 seconds and then we'll talk about it. Okay, fairly strong agreement there on 1, 2, 4, but we are spread across every answer. So we better be patient and careful as we go through this. If you see something that doesn't make sense, make sure you ask about it. I promise somebody else has the same question and they'll be glad you asked. So we'll start this out with our two-set Venn diagram. And let's see here. The first thing I want to shade is B complement. B complement. So that's everything outside of set B. So it's all of this for sure. And then over here. So that's B complement. If you don't see how that's B complement, it's okay to ask about it. And if you're thinking, I don't even know what to ask, sure you do. Say, why is region 4 shaded? Or why is region 1 shaded? Or why isn't region 2 shaded? Those would be perfect ways to ask, a question in this. Or whatever else comes to mind for you, it's okay. So there's B complement. Now I want to know, where does this intersect? So I'm going to be looking for that crosshatch, set A. So I'm going to shade set A in the other direction. Shade set A in the other direction. And I'm looking for the intersection, which is the overlap. I'm looking for the elements that are in both sets. I'm looking for the elements that are in B complement and in A. They have to be in both sets. They have to be in this crosshatch, the overlap. And when I do that, what I end up with is right here, just region 1. My final picture of my shaded B complement intersect A is just region 1. If this question had said B complement union A, then our answer would be regions 1, 2, and 4, but it didn't. It said B complement intersect A, so I'm looking for the overlap of those two sets. I'm not joining them together. And we wind up with just region 1 shaded. If there are any questions about that or shading two set Venn diagrams, now is the perfect time. Otherwise, we're going to go forward and take the degree of difficulty up a little bit. No, definitely not, Courtney. Definitely not. Especially with where we're going next. With the 3-set Venn diagram. A 3-set Venn diagram, we need a way to overlap 3 sets. We're not going to do that this way because you can see A and C don't have any overlap. What happens is C goes down here. And so I have sets A, B, and C. And we put a box around it. What happens when we go up to a 3-set Venn diagram is now we have more regions. We have region 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 regions in our 3-set Venn diagram. And that's where they're located. So when we're talking about region 2, we're just talking about this little sort of triangular shaped piece right here. If we're talking about region 6, it's just this little triangle shape over here, and so on. Before we start, well, we'll get to it with shading, I guess. I don't want to cut my legs out any. All right, so there's our 3-set Venn diagram with our 8 different regions. Now let's start shading. First one we're going to shade is just set A. We're going to keep this real simple, and it's exactly what you would expect it to be. I've got a three-circle diagram. With sets A, B, and C. And if I want to shade set A, I just shade in all the regions that are inside the A circle. Remember, set A is anything inside this circle. Anything inside the A circle, we've shaded set A. Now, when we look at the regions, there's quite a few of them there, right? We've got region 1, region 2, not 3, but region 4 and region 5. Set A would be regions 1, 2, 4, and 5. Let me know if you have questions. Don't overthink them. Shade set A means color in the A circle. Whatever regions that happens to be, that's what regions are shaded. The thing that might be a little challenging at times is something involving a complement. If we want to shade a complement, we'll have our 3-set Venn diagram. And now that's everything outside of set A. All right, well, it's going to be all this stuff for sure. And then everything outside of set A. The way that I do this, like, visualizing things, art is a little bit of a challenge for me. So I kind of imagine this wall right here, and I don't want to shade anything inside there. I only want to shade stuff that's outside of there. So that leaves me with over here, like that. What we ended up with shaded there for a complement then is, let's see, region 3, not 4, not 5, region 6, region 7, and region 8. One thing I want you to notice is if I look at, well, what's shaded for set A? That's 1, 2, 4, and 5. So what's shaded for a complement? That's, oh, y'all didn't catch me on that. That shouldn't be 4. It should be 3, 6, 7, and 8. 3, 6, 7, and 8. Sorry about that mistake. We'll pause here for a minute because I goofed it up the first time. So when I shaded set A, it was 1, 2, 4, and 5. When we shaded a complement, which is everything else, it's 3, 6, 7, and 8. All the other stuff. If we put those together, it'd be 1, 2, 3, 4, 5, 6, 7, 8. It would be everything. And so a complement is everything else, everything that's not inside set A. Here, that's regions 3, 6, 7, and 8. Any questions about that? The complements might be the thing that is challenging, so I want to make sure we're comfortable with complements. All right, I'm going to try A intersect B. You can too. I won't be in a big hurry here, so that you can try A intersect B and see what you end up with. We'll start out with a 3-circle diagram. And I want A intersect B. Some of you are probably already at a place where you can color in where A overlaps B and you just need one picture and you're all done. If you're there, that's fantastic. If you're not, that's completely fine. The first time you saw this might have been 40 minutes ago. So give yourself a break. It can take a little practice. So what I want to do is A intersect B. So first I'm going to shade set A. And then I think to myself, okay, this one is intersection. That's the overlap. That's the elements that are in both sets. That's the elements that are in A and B. Because I'm looking for the overlap, I need to shade this both directions. So I'm going to shade set B the other direction. And now I'm looking for the overlap of A and B. What regions make up the overlap of A and B? If you don't know, that's okay. If you do know, that's excellent. 2 and 5, 2 and 5, 2 and 5. Outstanding. It's 2 and 5. Very good. Perfect. As I look at this picture and I look for the overlap, I can see that it's in here. There's the overlap of A and B. And so just to sort of clean this up and have a nice tidy picture to finish with, that's how I would say this is like a cartoon strip, is we'll draw another picture that sort of tidies it up a little with A, B, and C. And then just to have a nice tidy final picture, A intersect B is going to be right there, and that's regions 2 and 5. One thing I want to say about this, because it's a question that is common, and if you're having this question, you're right in line with a typical student who hasn't seen this before. If you're thinking, it's A intersect B, but some of this is in set C. You're exactly right. Some of it is. But remember, what we're trying to shade here is the overlap of A and B. Well, here's where A goes. Look at that. Some of the elements of C happen to be in A. And here's where B goes. Some of the elements of B happen to also be in set C. And so where A and B overlap, those just happen to contain some elements that are also in set C. That's okay. That doesn't mean they can't be in this overlap. It just means they also happen to be in set C, and that's just fine. So we don't want to throw out region 5. We want to keep region 5 because the elements in region 5 are in set A and they're in set B. So we want to keep those in our picture. Let's try some more. A union B. I'm not going to do a poll for this one, but I am going to go slow and give you a chance to draw it. We're talking about a 3-set Venn diagram. So we're going to have A, B, and C. We're going to have that box around them in case we have anything outside those 3 sets to deal with. So there's our picture, and we want to shade A union B. Well, I'll go slow. But one thing I do know right away is it's union, which means I'm going to join these sets together, which means I'm just going to shade the same direction. I don't need to look for an overlap. I'm just joining them together. With intersection, I need that crosshatch, so I shade opposite directions. But with union, I'm just joining them together, so I'm going to shade the same direction. I'm going to shade set A, and then I'm going to shade set B. And so there's A union B, and it turns out to be, let's see, what regions do we have here? We have region 1, 2, 3, 4, 5, and 6. So A union B is regions 1, 2, 3, 4, 5, 6. Everything inside those 2 circles. Yeah, but some of it's in C. Yeah, you're right. That's okay. There's an overlap between A and C. There's an overlap between B and C. What we're shading is everything in A joined with everything in B. So we need to count 4, 5, and 6. Those need to be shaded also. That's where I say don't overthink it. If you're shading set A, color in the whole circle. All right, let's have you try one. B intersects C in a 3-set Venn diagram. Just like last time, I'll set up a poll for this. I'll give you some time to try it. we'll go another 15 seconds and then talk about this. When we go through it, if you have questions, make sure you ask them. If you're doing really well with this, that's excellent, because for most of you, I'm guessing you've never seen this before. And I don't know, I guess that's not necessarily true, but a lot of people probably haven't seen this before. And if you're picking up on it already, that's great. That's really great. All right, let's see where we are. Okay, almost unanimous. That's excellent. All right, let's take a look at this one. If you have questions about where anything came from, please don't hesitate to ask. Not only is your question going to help people with this question, it'll help people with other questions also. So B intersects C. Let's take a look at this. So I have my 3-circle diagram. That. And then I'm trying to shade B. So let's see, that's everything inside the B circle. This time it's intersect. So I'm looking for the overlap, the elements that are in both sets. So I need to shade the other direction. So when I go to shade the other direction, when I shade set C in the other direction, and then I look for the overlap of those two sets. And when I look for the overlap of those two sets, I can see that this region and this region have the crosshatch in them. So that's going to be regions 5 and 6. If it were union, it would have been 2, 3, 4, 5, 6, 7. But it was intersection. I wanted the overlap. I didn't want to join them together. And, you know, just to kind of draw a nice tidy picture of this at the end, I might go ahead and have ABC, box around them, and color that in. There's a B intersect C. Some of you may be able to look at a picture already and say, well, I'm just looking for the overlap of B and C. So if I look at the B circle and I look at the C circle, I can see that B intersects C is right here. If you're there or you're getting there, that's excellent. There's nothing wrong with that. If you want to do it in stages and look for the overlap, there's nothing wrong with that either. Let's throw in parentheses. So I have A intersect B union C. So, you know, we're gradually climbing this mountain. A intersect B union C. I'll draw this one, but I'll do it slowly. If you want to give it a try, I think that's a great idea. If you want to give it a try, it's a really good idea. And I'll do it slowly so that you can kind of see if you're doing the same things I was. And if you have any questions you want to ask, that's great. One thing I will say, we have parentheses, so we're going to start over there and do the intersection with set A last. Same thing we did last week when we were looking at roster sets in roster form. Parentheses go first. After you kind of get the hang of these, and that last poll went extremely well, I think they're kind of fun. You know, we're just drawing pictures of stuff. I know what union is. I know what intersection is. I'm just coloring them in. Hopefully, you kind of see it that way too. I'm starting out with B union C. Some of you are probably already at a place where you can color in B union C right out of the gate. Fantastic. If not, one step at a time, I'm going to shade set B. And because this is union, I'm going to join those two sets together. So I'm going to shade set C in the same direction. And that's everything inside the C circle. And so there's B union C. And some of you, like I said, might have gone straight to there when you saw B union C. If so, that's excellent. Great. All right. The next thing I need to do is I need to find where does what I have now, what I've completed so far, where does that intersect set A? Since I'm looking for where this intersects set A, I'm going to shade set A in the other direction. And now I look for the overlap of these to give me my final picture. I've got set A, set B, set C, and I need a final picture here. Let's see, what is it that I have shaded? Well, it looks like this part, and then this part over here. And so what I wound up with for the regions that are associated with A intersect B union C, that's, let's see, regions 2, 4, and 5. And Courtney, you asked earlier whether or not intersection would only have one section. Well, here's a perfect example where we had an intersection and we wound up with 3 sets or 3 regions. So especially in our 3-set diagrams, it can be, it could be 1 region or 2 region or more. Are there questions about this before I have you try one? Outstanding. Okay. Let's throw in a complement. A intersect B union C complement. This is a pretty hard question. I'm not going to lie. This is a pretty hard question. And we're going to do it left to right. We don't have any parentheses. So you're going to start by doing A intersect B, and then whatever you have, join it with C complement. I'll set up a poll for this, and I'll give you a chance to try it. Like I said, this one's pretty challenging. It's also the last poll I have for us today, so we can be really patient on this one. We'll go another 20 seconds and then talk about this. All right, let's take a look. Okay, fairly strong agreement, but we're a little bit split. So, and we do have answers for each. So let's be a little careful here as we go through it. So A intersect, B union C complement. Okay, so we'll start out with our three-set Venn diagram. If you see anything that you're unsure of or doesn't make sense, please let me know. The first thing we're going to do is shade A intersect B. This kind of depends on where you are. Some of you will be able to look at this and go, well, A intersect B is right here. Fantastic. Others will do this step by step, and that's okay. It's shade set A. And then I want to know where this intersects set B. So I'm going to shade set B in the other direction. And then I look for the overlap of those two sets, and that's right here in regions 2 and 5. So what we have so far, A intersect B in our three-circle diagram, is regions 2 and 5. If you don't see that, please don't hesitate to ask. A intersect B is regions 2 and 5, and it's that picture over there on the right. The next thing we want to do is we want union. So we're going to join this with C complement. So I'm going to join it. So I'm going to shade the same direction. I'm not looking for an overlap. I'm just putting these things together. I got to join whatever I have now with C complement. I need to figure out what C complement is. Well, C complement is everything that's outside of C and inside my rectangle. So everything outside of C is going to be this stuff for sure. And then everything outside of C, so that's over here. And so there's my final picture of everything shaded. I shaded A intersect B, gave me this sort of football shape right here. And then I joined that with everything that was outside of set C. And I ended up with 1, 2, 3, 5, and 8 shaded. There's always a question about 5, like, hey, you said C complement, how come 5 shaded? Well, remember, it's because of union. We joined it with A intersect B. It's an excellent question. If you were thinking, how can region 5 be shaded? You said C complement. Well, C complement's a piece of this, that's true, but this is joined with A intersect B. And so that's why region 5 is a part of our answer. That was the most common thing not included in the correct answers this time, was region 5, and that's the reason for it. It's true, region 5 is not a part of C complement, but region 5 is a part of A intersect B, so it needs to be included in our answer. Excellent, Jessica. Very good. We did, if it was intersect C complement. Okay, we could do that. Absolutely, Nicole, or Natalie, we could do that. Not so much once it's locked in, it can't be changed, because you'll notice, Nicole, at the beginning, or actually, let me go back and, oh yeah, here's one, it's perfect. When we shaded set B, we included region 6, but region 6 isn't part of our answer. So just because something gets shaded somewhere along the way doesn't mean it's necessarily going to be shaded at the end. We just have to kind of be flexible and roll with it. Whatever the problem has us do, that's what we end up with. Natalie's question's a good one. What would it look like if it was intersect C complement instead of union C complement? So let's take a look at that. So we'll have A intersect B intersect C complement. So if we wanted to have A intersect B intersect C complement, we're still going to go left to right. And I'll have A intersect B, and so I'll have set A. I'll go a little faster this time. If it's too fast and you want to ask questions, you can. Intersect set B, so I'm going to shade B the other direction. So where I am when I have A intersect B is just right here. And then if I wanted to intersect with C complement, then I need to shade C complement the other direction. So everything outside of C gets shaded the other direction. And then I look for the overlap. As it turns out, the overlap of those two sets is just region 2. That's it. So if I want the intersection of A intersect B intersect C complement, it's only region 2. All right, I had one more shading I wanted to look at with you. Something we haven't done yet. It involves intersection, union, complement, and parentheses. It's all in there. I'll let you try this one for a second, and then I'll start drawing it. I don't have a poll set up for this one. I wasn't sure if we were going to do it or not. To be honest, I wasn't sure how much time we'd have left when we got to this point, but I think we have enough time to try this one. So I'll let you try it for a minute, and then I'll jump in and start. All right, so I'm going to have a 3-set Venn diagram. I have parentheses, so I've got to do what's in there first. So my order here is going to be, the first thing I'm going to do is B union C. Then I'm going to deal with this parentheses out here, or excuse me, apostrophe out here and take the complement. Pen didn't show up there. Give me a second while I get my pen back working again. Okay, I think we're good. So the first thing we're going to do is B union C. Second thing we'll do is the apostrophe to take the complement of that. And then the last thing we'll do is intersect with set A. All right, I'll go through this one. We'll have set ABC. I start with B union C, which means I am going to shade set B. And because it's union, I'm going to shade set C in the same direction. Now I want the complement of that. This is the idea that the light switch thing, where, okay, if that's what B union C looks like, then B union C complement is just going to be the inverse. Whatever is shaded now won't be, whatever isn't shaded now will be. And what I'll get then is, let's see, well, this is going to be shaded 2, 3, 4, 5, 6, 7, and over here. So B union C complement, and those of you who are really good visually will say, well, sure, it's everything except B union C. Regions 1 and 8. Great. That's what we end up with B union C complement. And then the last thing we need to do here is we need to look for where does what we have now intersect set A. So we'll shade set A in the other direction. And it looks like we end up with the only thing shaded in all of that. We had to do all of that. B union C, take the complement, and then intersect with set A, and all we wound up with shaded was region 1. That's it. Any questions about that before we try a couple more things? This is as difficult as a shading question can get, but there are a couple other things I do need to talk about today. All right. There might be times where you're given a Venn diagram and you're supposed to find the notation. Our book sometimes calls the notation symbolic language. I might just say symbols. When that happens, you might see something like this. Set A, set B. We have this two-set Venn diagram, and the picture that we're given is that. And the question is, what symbols would you use to get this picture? I think these are pretty challenging questions, but we have a method for attacking them, and I think trial and error is great here. If you look at that and you're like, okay, it's a two-set Venn diagram, I'm going to try A intersect B and see what happens. And so you draw it. You draw A, you draw B, you do the intersection of those. Is my picture the same as the picture I was given? No, so that's no good. That's not going to work. Okay, well, this has A, but it doesn't have B. Some of you might be able to look at this picture and go, well, what you're looking at here is inside of A, but it's outside of B. How might I write that down? If I wanted inside A and outside B, how might I write that down? And everything you need is right here, inside A and outside B. How would I write that down? What symbols would I use? Heck, let's start simple. How would I write inside A? If I wanted just to write inside set A, what would I put? And if you're already for the answer, Courtney, hold up. If I just wanted to say something was inside A, what would I do? Don't overthink it. If I want to say it's inside A, I'm going to put this. It's inside set A. Okay, then. What if I want to say it's outside of set B? How would I write outside of B? I don't want inside B, I want outside of B. How would I write it? Perfect. B complement. And the word and, what does that go with? Intersection or union. It's one of those. And goes with rats. um, when we're looking for things that are in the overlap, they're in both sets. They're in A and they're in B. That's intersection. When we want to join them together, they're in at least one of the two sets. They're in A or B. That's when we use union. So or goes with union and goes with intersection. This is going to be intersection. So what I'm going to try here is A intersect B complement. And I'm going to try to draw that. And I have set A, which is here, and then B complement the other direction. And I end up with just region 1 shaded. That's my picture. So A intersect B complement is what we're after. So what I was looking for in this picture was inside A and outside B. To get there, I'll just write that down. And the way that I write that down is inside A and outside of B. Some of those can be a little challenging. Don't be afraid of trial and error.